Hello, Club, and any other child that's going to see this, because if you're in Sandu's class, God knows you need the help. Okay, so you have parabolas, right? You'll have the y equals ax squared plus bx plus c. Now, if you already think you know what I'm going to say, don't skip it. But if you actually already knew what I was going to say, then why are you watching this? Okay, next question. So we have this formula, right? We know that this, hang on a second. Oh my God, these are so straight. This is taking up the whole video. Okay, so we have this formula, right? Now, what does each value do? We know the c value is the y-intercept. And we know, well, the b value doesn't really matter, but we know the a value. What does the a value do? Significance of a value. Right? So what does this mean? Well, number one, it basically means if it is going to face up or down. Basically, if the a value, okay, I'm going to put it a value is negative a, right? So if the a value is negative, then it looks something like this, right? And the vertex would be here. And then if the a value is positive, then it would go up like this. If you have trouble remembering, smiley face, positive, sad face, negative. Okay? So now that we have that sorted out, how do we find the domain and the range? So, what is the domain? Domain. Okay. To try to, what's the word? I forgot. Minimize confusion. I'm just gonna say it outright. Usually domain can mean everything. So, if like, it can equal any real numbers, you just put XER, means any real numbers, right? For example, if you go on the graph, you can go to any value and the parabola will be somehow there, right? Somehow, right? If you go to this value, this X value, right? You're gonna get a Y value. If you go to even this value, because it's continuous, right? It's infinite, then you're gonna get a Y value, right? However, that does not apply to the range. Now, the range is the y value, basically. The domain, where we can choose any x on the graph, and then we'd get a y value. But we can't choose any y on the graph and get an x value. You see here, it kind of looks like boobs. Okay, if you see here, right, the range, I'm going to just write it here, y value, right? Okay, now what I want you to focus on is the vertex. Let's try this one. The vertex, right? Okay, so the vertex means that nothing will be under the vertex, because the vertex, it just like kind of sprouts out of the vertex. Kind of like, you see how it's just like sprouts out? That means it won't suddenly go like whoop-de-doo, right? It'll go symmetrical like this. And because of that, the graph will not go lower than the vertex. Like, you won't find any point here that aligns with the graph, right? For example, it can go higher than the vertex because the parabola itself, the a value, is positive. So it's going up, right? It's facing up. And these arrows means that it's continuous. Even when it exceeds the graph, it's still going to go out on its own and have its own adventures, you know? Same with this. If it's negative, you won't find any y value here and stuff like that, right? Shit, I forgot to draw arrows. But the arrows here indicate that it will continue going down like this and blah, 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 right? It will have its own adventures outside of the graph. So, the domain and the range are basically just the restrictions. If there are any restrictions on the graph, you have to state them, right? Now, let's see here. Now, we or I hope you understand now. Basically, the graph cannot go lower than the vertex, right? Now, how do we represent that? Now, we write it as, let's just say that the vertex for this is -2, -5. I'm just bullshitting numbers out here, right? That will be the vertex, right? So then we look at the y value, -5, right? The graph will not go lower than -5. Never, ever, ever. Right? So then now we just put it as y is bigger or equal to -5. So y can be -4, y can be -3. It can be any number bigger than -5. Now, can it be -6? I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is no. What did I just explain to you? Now, if you got it right, congratulations. But if you got it wrong, rewatch the video. So I made it very clear that the vertex is basically the point where it sprouts out, right? Whether it's downwards or upwards, but it can't be both. So that would be the range restriction on this. Now let's try to find out on the negative graph where it's going down, right? Now, if I say the vertex is 1, +3, right? That's the vertex. What would you say the x, or sorry, not the x, the domain is? If you said that x can be all real numbers, correct. Congratulations, right? X can be all real numbers. If I choose a point here, it will somehow eventually get its y, even if it's off the graph, right? However, I have to say another sentence before the however. Ugh, okay, fuck, my knee. Okay, so, but can y be any real number, or does it have to have a restriction? The answer is it has to have a restriction. You see here how the graph is just sprouting down. It's not going to end up sprouting up, right? So that means that the y value of the vertex is 3, right? So that means y will be smaller or equal to 3. Like 3, and y can be 2, y can be 1, y can be 0, y can be -1. But however, it cannot be 4. I hope you get that. Okay, now a little recap. So, the thing that you need to pay most attention to first is when it's in this format, you pay attention to the a value. Now, what is significant about the a value? It indicates whether it's going to go down or it's going to go up. If the a value is negative, then the parabola is going to go down. Now, if the a value is positive, then the parabola is going to go up. Try to think of it as like negative, sad face, positive, happy face, right? That's what you're going to think of. Now, basically, the domain and range are the restrictions you're going to put on the parabola, right? So, let's start with the domain. The domain is x, right? Let's see if we can put any restrictions on x. Now, if we go on any point of this graph, right, there will always be a y value. Whether or not it's shown in the graph, these arrows indicate that it's going to be continuous, that it continues on forever, right? So you can choose any x value and you will get a y value in return. So that's what XER means. XER means that x can equal any real numbers, right? Or any or all real numbers. Now let's move on to the range. The range is the restrictions on the y values, right? So if we move to any point of this graph, for example, if we look at, okay. So if we choose the y value as like -6 and we try to find an x value, right? We look around the graph. Oh shit, there's nothing, right? That's a restriction we have to put on the graph. If we look at this, we make the y value like 4, right? We look around the graph for like a x value in return, right? Wait, hang on. Let me think about this. Yeah, like that's not gonna happen, you know? So basically, the y value, or the y value restriction, you're just gonna look at the vertex, right? And then see the y value of the vertex and see if it's gonna be, if it's a negative parabola, if it's facing down, then it's gonna be y is going to be smaller or greater than the vertex, right? And if it's facing up, it's going to be y is bigger or equal to -5, right? The reason for that, like let's take this, the vertex is -5, right? There are no y values below it. It's not going to happen. Same with this, there are no y values above this. So that's basically how you find the domain and range.